All right, so this is the last part, and again, I apologize for how long this is taking, but we did have to go through each one of these examples. So the last example that we're going to talk about is where you see the degree on the top being greater than the degree on the bottom. These ones are actually not as bad because the bottom is fairly easy to do, and the top one is typically a factoring one. But because the degree is higher than it is on the bottom, we're going to end up with no horizontal asymptotes. So we have less asymptotes to deal with. So what's going to happen here is we still want to do everything the exact same way. We want to factor the top. So this one, because it's minus 2 and minus 3, this ends up being x minus 3 and x plus 1. Okay, so actually that can go right down here. So x minus 3 and x plus 1. So the x-intercepts are 3 and negative 1. Okay, and then we look at the 0 of the denominator. So we're setting the bottom equal to 0 still for the vertical asymptote. So the 0 there would be negative 2. So therefore the vertical asymptote is negative 2, or x equals negative 2. Okay, now the degree of the numerator, as we said, is 2, and that's greater than the degree of the denominator, which is 1. So the graph has no horizontal asymptote. Again, that goes back to our rules. If the top has a higher degree than the bottom, we have no horizontal asymptote. So this part we're not going to worry about. It says the graph has the same end behavior. Don't even worry about this. We're not going to talk about end behaviors. While they can be important and they can be useful, I don't want to me it gets really confusing by doing that. So again, what we're going to do is plot everything we have. X-intercepts, plot negative 3. So these are going by 2's. So negative 3 is right here. I'm sorry, messed that one up. Positive 3 is right here. And negative 1 is right here. Okay, so those are our x-intercepts. And then we have one asymptote at x equals negative 2. So let's plot that. Okay, so there's our vertical asymptote, and that's the only asymptote that we have. So what we need to do is we still need to plot points on our graph. So that's what we're going to do in this chart right here, is same thing. We're going to plug these into our function. So quickly, I will give you the values that we have here. We have negative 12. We have a negative 11.25. We have negative 10.5. We have negative 12 again. Okay, and those are all the values to the left. So to the left of the vertical asymptote. So you can go ahead and plot those. And you can do these one at a time, or you can do them all at once. But obviously, we're separating these by left and right for a reason. Maybe you want to do that when you're doing it, so that way you don't get confused and you're not connecting lines between the asymptote. That is up to you, whatever is easiest for you. So we have negative 2, negative 4, negative 6. So we have negative 7, 2, 4, 6, 8, 10, 12. So our first point is right here. Our next point is negative 6, 11.25. So that is somewhere right around here. Then we jump to negative 4 and negative 10.5. So that is, actually this should probably be further down. This should be more like right here. And this one is going to be more like right here. And then our last one's back at 12. And then again, do the best that you can to connect this curve. You know it's going to be a curve. It's not going to be a triangle. You shouldn't have any straight edge points. It should all be curved. But that's approximately what it looks like. And again, when you have problems with this, when you're not sure what the graph's going to look like, just go ahead and pop it in your graphing calculator, put it in there and see what the curve looks like so you get a general idea. But I still am going to want to see these points. You're going to need to do this process. I don't want to see sketches from your graphing calculator. We're kind of past that. Okay, so now we do the right side. We have negative 1, which is 0. We already found that. We have 0, which is negative 1.5. And we have 2, which is negative 0.75, and then we have our other x-intercept that we've already plotted. So this will be perfect. So we have -1 comma 0 already plotted. We have 0 and then -1.5, which is right around here. And then we have 2 and then -0.75, which is right around here. And again, our graph is fairly easy to sketch from there. And that's what our graph looks like. Okay, so this is not quite as, in depth as what the previous one was, but it's just a different type of problem. So now you do your domain. Same concept, all real numbers because it goes completely left to right. Except for our asymptote, which is at -2. So we would say x is not equal to -2. Now our range is a little bit different. And here's what I'm going to tell you about this. I'm not going to be too picky about this. All I want you to do is think about, okay, what is the highest point here? You can pick one of the points that you have where you did your turning point. It's going to be very hard for you to be exactly right on this. So if that's the case, then just approximate. So I'm going to approximate that this one is at a -10.5 because that's as high as we go. So therefore, y will be less than or equal to a -10.5. Why? Because we're starting at 10.5 and then we go straight down. And then we also have to do this one up here, and the lowest point there is -1.5 about. So I'm going to say y is greater than or equal to -1.5. Again, the range is representing what y values are represented on the graph. So this goes from 1.5 all the way up, so y is greater than -1.5. And then this is -10.5 all the way down, so y is less than or equal to -10.5. Okay? So hopefully that makes sense. And again, go through this first one on your own. Only do the first one, and then you'll see the answer, see if you're doing it right, and then you're going to have another one to do on your own down below. So this is just giving you some extra practice. So hit play when you're ready for the first one. Follow along on this first example to help you through it. All right, so you see your results on the graph here. Again, same process. We have x-intercepts are from the factored portion of the top of the function. So factor that, you get x plus 4, x minus 2. X-intercepts are x is -4 and x equals 2. Plot those on your graph. Your vertical asymptote comes from the bottom of the function. X minus 1 equals 0, so x equals 1. Plot that. Because the degree on the top is higher than the degree on the bottom, we have no horizontal asymptote. Down below is our table. Again, you may not have used the same values, but as long as the graph looks approximately the same, that's good. And then in this one, the domain, again, same idea. All real numbers where x is not equal to 1. The vertical asymptote's the only thing that changes that. On this one, because of the shape of our graph, you can see that our graph goes all the way up and all the way down on both sides. So our range here is actually all real numbers. There's no restrictions on our range. So that will be all real numbers. Make sure you look at your graph to help you with the range. Okay, so go ahead and do the other one and hit play, the bottom left one, and hit play when you guys are ready. Okay, so for this last one, it's pretty similar to the ones we did before. Factor the top one, you get x plus 5, x minus 5. That gives us our x-intercepts. X equals -5, x equals 5. Vertical asymptote, again, comes from the bottom. So that's going to be x equals 4. So we plot our intercepts here. Here's x equals 5. Here's x equals -5. Notice the graph's going by 4s, so that's why it's so close and maybe a little bit off from what you're thinking. But it goes by 4s. Again, the degree on top is bigger than the degree on the bottom, so we have no horizontal asymptote. Here's our table of values. Again, you may not have used the same values, but just make sure that the graph shape looks approximately the same. With the domain, we have all real numbers except for our asymptote, so x cannot equal +4. And then our range, again, we have values that go all the way down and all the way up. So therefore, our range has to be all real numbers here. Again, when you're in class, use the graphing calculator to help you with this, just to check to see if the shape is right. So before you actually connect all your points, make sure that the shape of the graph looks approximately right with your points, and then you can go ahead and do it. So again, sorry for the long videos. Hopefully, we went slow enough for this to make a little bit of sense. See you tomorrow. Take your quiz.